This is the video for Module 14, Section 4.3, about solving systems of linear equations by addition. In the previous two sections, we've talked about two methods that we can use to solve systems of linear equations. One method was by graphing, another method was by substitution. The third method we're going to learn is addition. It's also sometimes called the elimination method. The goal in this method is to add the equations or equivalent forms of the equations together in such a way so that one of the variables is eliminated. For example, if we had this system of equations, notice that the first one has a 4y and the second one has a negative 4y. So if we could add corresponding pieces of these two equations together, the 4y and the negative 4y would cancel each other out. And that's exactly what we're going to do with these in this method, is that once we line up the variables and the constants so that they're in the same positions in each equation, then we can actually just add the equations vertically like this. So if we have negative x and negative 6x and we add those, we would get negative 7x. Then here if we add the 4y and the negative 4y, those two cancel out, so we get a 0 there. And on the other side, we also have to add the 5 and the 23 to get 28. Now, because we have two equations, we can add corresponding sides of the equations and get something else that is an equation. The goal in this method is to add the equations together so that one of the variables is eliminated, which is exactly what happened here. We have an x term, but no y term. And this one would be easy to solve for x now. So to use this method, the first thing that we'll need to do is rewrite the equations in the system so that they're in the same form, so that the variables line up in the same positions and the constants line up in the same positions in each of the equations. Then, if necessary, we'll multiply both sides of one of the equations or both of the equations by a constant so that we get an equivalent equation. Then we'll add the equations vertically, and you do have to remember to add on both sides of the equations. Then with the resulting equation, we'll be able to solve for one of the variables, since one of the variables will have been eliminated. After we solve for one of the variables, we'll use that value in one of the original equations to solve for the other variable. Here are some examples. The first thing to do when using this method, again, is to make sure that your variables and constants are in the same positions in each equation. So if we look at our two equations, we have our x terms first, and then our y terms, and our constant terms are on the other side of the equation. So these are already all lined up for us. So next we want to look at what we have, and this is in fact the same example we looked at a little while ago. With these two equations, we already have the 4y and the negative 4y that will cancel each other out if we add these together as they are. So we don't have to multiply by anything in this case. So let's rewrite our two equations. And now we're just going to add these vertically. So we have negative x plus a negative 6x would give us negative 7x. 4y plus a negative 4y would give us a 0. So you can either write the plus 0 in there, or you can just leave that part blank. And then do remember to add on the other side of the equation also. So we have 5 plus 23 is equal to 28. Now once we've done that, we should have eliminated one of the variables. So we're going to take this equation and let's rewrite it so that it just looks like negative 7x equals 28. We can easily solve this one for x by dividing by negative 7 on both sides. That's going to give us x is equal to negative 4. Now from this point, this method is similar to what we did with the substitution method in that we use this value go back to one of our original two equations and substitute this value back in to solve for the other variable. So we're going to substitute this in one of these two original equations. Notice it has to be one of these two. It cannot be the one that we got as a result of adding them together, because that wouldn't work. So let's just use this first one. So we have negative x plus 4y is equal to 5. We could easily have chosen the other equation to substitute into also. So in place of the x, we're substituting negative 4. And now we're going to solve this for y. All right, so the opposite of negative 4 would be plus 4. If we subtract 4 from both sides, we end up with 4y is equal to 1. Now if we divide both sides by 4, we end up with y is equal to 1/4. Now we have both of our values for our solution. We have the x is equal to negative 4 and the y is equal to 1/4, which would give us the ordered pair negative 4, 1/4. Now we do want to check this. So we're going to use our ordered pair, put it into both of the original equations and make sure that we get true statements from each one. So putting it into the first equation, we're substituting negative 4 for x and 1/4 for y. So that gives us a positive 4. The 4 and the 1/4 cancel each other out here to give us a 1. And we end up with 5 on both sides. So that one checks. Substituting our values into the other equation, we have negative 6 times negative 4 minus 4 times 1/4 is equal to 23. So that gives us a positive 24. Again, the 4 and the 1/4 cancel each other out, and we have a negative 1. That gives us a 23 on the left side and a 23 on the right side, so that checks. Our solution is the ordered pair, negative 4, 1/4. Let's look at our next example. Remember that our first step is to make sure that all the variables and constants are lined up in the same way in each equation. In this one, they're not, so we're going to have to do some rearranging first. Let's write both of these equations so that they're in the same form as the last example. So we'll have the x term first, and then the y term, and then the constant. So we'll have an x term and then a y term, and then on the other side of the equal sign we'll have the constant. So for our first equation, to do that we would just have to add 3y to both sides. So we'd have x plus 3y is equal to 2. And for our second equation we have to do a little bit more. We're going to have to add 2x to both sides. So we have a 2x on the left side. We can leave the y on the left side since it's already there. And then our constant needs to go on the right side, so we'll have to add 9 to both sides. Alright, so now our variables and our constants are all lined up. Now looking at these two equations, if we add these, we won't automatically get one of the variables to cancel out. So what we'll need to do is multiply one of the equations by something, so that we will eliminate a variable when we add the two equations together. Let's look at our x terms. Since we have an x and a 2x, it would be easy to multiply this equation by negative 2. That would give us a negative 2x, which would cancel with the positive 2x. So let's rewrite our first equation, multiplying through by negative 2. And when we do this, we have to multiply each term on each side by the negative 2. So negative 2 times x plus negative 2 times 3y We also have to remember to do this on the other side. So now that will give us an equation, negative 2x minus 6y is equal to negative 4. So that's our new first equation. Now let's rewrite our system. So now we have negative 2x minus 6y is equal to negative 4. And our second equation was 2x plus y is equal to 9. Now we can add these together, and our x's cancel out. Negative 6y plus y would give us negative 5y, and negative 4 plus 9 would give us 5. That gives us negative 5y is equal to 5, and we can divide both sides by negative 5. That gives us y is equal to negative 1. Now to solve for x, we want to go back to one of our original equations. In fact, let's go back to our original first equation right here, because the form that it was in to begin with, it was solved for x. So we can easily put our y value in there and find out what value x has. So this would be x is equal to 3 plus 2, so we would end up with x is equal to 5. So now we have our x value and our y value. That gives us an ordered pair of 5, negative 1. We want to check this solution. So we're going to check it in our original two equations. In the first equation, we have 5 is equal to negative 3 times negative 1 plus 2. That gives us 5 equals positive 3 plus 2. So that one checks. In our other original equation, we had y minus 9, so that would be negative 1 minus 9 is equal to negative 2 times 5. So this would be negative 10 on the left side, and negative 2 times 5 is negative 10. So that one checks also. Our solution is the ordered pair that we came up with. 5, negative 1. Let's look at two more examples. In this first one, again, we're going to have to rewrite our second equation to get it in the same form as our first equation. So let's rewrite our system down here. The first equation is fine. For the second equation, we need to move our y term over to the left side. We can do that by subtracting 3y from both sides. That gives us 5x minus 3y is equal to negative 26. Now, looking at these, we need to figure out what we can do to get one of the variables to be eliminated when we add our equations together. And in this one, actually, we're going to need to multiply both equations by something in order to achieve that. One way you can do this is just pick one of the two variables that you want to eliminate and look at the numbers that you have. For example, with x, we have a 2 and a 5. The least common multiple of 2 and 5 is 10. So if we multiplied by something so that we had a 10x and a negative 10x, those two would cancel out. So let's multiply this one by a negative 5. That will give us our negative 10x, and let's multiply this one by a positive 2. So that will give us a positive 10x and a negative 10x. Okay, so for the first one, if we multiply through by negative 5, we have negative 5 times 2x plus negative 5 times 7y equals negative 5 times 6. That would give us negative 10x minus 35y is equal to negative 30. So this is our new first equation. For the second equation, we're multiplying by 2 on both sides. So we'll have 2 times 5x minus 2 times 3y is equal to 2 times negative 26. That gives us 10x minus 6y is equal to negative 52. So this would be our new second equation. So now let's write our system, our two new equations. And we have what we wanted, which was that we have a negative 10x and a positive 10x. So when we add those together, those two just give us 0. Then negative 35y and negative 6y would give us a negative 41y. On the other side, we have negative 30 and negative 52, which would give us a negative 82. Now, if we divide both sides of this by negative 41 to solve for the y, we're going to end up with y is equal to 2. All right, so we've solved for the y. Now let's go back to our original first equation and use that value of y to solve for the x. So we're substituting 2 for y in our original first equation. Now we have 2x plus 14 is equal to 6. If we subtract 14 from both sides, we end up with 2x is equal to negative 8. If we divide both sides by 2, we end up with x is equal to negative 4. So now we have our x is negative 4, our y is equal to 2. That gives us an ordered pair, negative 4, 2. Let's check our solution. So in our original first equation, we're substituting negative 4 for x and 2 for y. We have negative 8 plus 14 is equal to 6, and that gives us 6 on both sides, so that one checks. The original second equation, we have 5 times negative 4 is equal to 3 times 2 minus 26. That gives us negative 20 on the left side, and 6 minus 26 on the right side. And we have negative 20 is equal to negative 20, so that one checks. So that gives us our solution of the ordered pair, negative 4, 2. Okay, one more example. In this one, we already have our variables and our constants lined up. So let's look for something that we could multiply one of our equations by in order to get one of our variables eliminated. There are two good options for this one. Since we have a 20x here, we could multiply our 4x by a negative 5. That would give us a negative 20x, so we could cancel our x's. Or with our y's, since we have a 6y and a 30y, we could multiply the 6y by a negative 5 to make it a positive 30y, and that would eliminate the y's. So really it doesn't make any difference which one of these we do. So let's multiply let's decide to eliminate our y's. So that would mean that we'd have to multiply this by a negative 5. So for our first equation, we're taking negative 5 times 4x minus a negative 5 times 6y is equal to negative 5 times 1. That gives us a negative 20x. This would be a positive 30y. And on the other side we have a negative 5. So that's our new first equation. Now if we rewrite our system, negative 20x plus 30y is equal to negative 5. Then our second equation was 20x minus 30y is equal to 3. So if we add our two equations together, look what happens. We get not only our y's to cancel, but also our x's are going to cancel. A 0 there, a 0 there for the y's, and on the other side we still have to add these two together. Negative 5 plus 3 gives us a negative 2. So we end up with the equation 0 is equal to negative 2. Now we've eliminated all of our variables, which means that we've got one of two situations. Either we have a consistent system where the equations are dependent, where the equations actually represent the same line, or we have an inconsistent system where the lines are parallel. And since what we've got down here, 0 is equal to negative 2, is a statement that's always false, that means that our system has no solution. And that would mean if we were graphing this, that the lines are actually parallel. Now, if our statement down here had come out to be something that was always true, for example, 0 is equal to 0, then our answer would have been that we have an infinite number of solutions and the two equations actually represent the same line.